Thank you. Yeah, so I'm going to talk about Ecto today, but first I want to talk about where I work, which is at Cabify. It's a it's a it's a company located in Spain. Our main product is a ride-hailing app. The markets are Spain, Portugal, and Latin America. I believe we are one of the largest Elixir teams in Europe. And we have both local and remote positions. So if you want to work here, please come and talk to me or find me online. All right. So Ecto is a database library. And before we get into it, I want to talk a bit first about some of the concepts that are kind of core to how we design the library and sort of the ideas behind it. So first off, it's composable. So what that means is that we try to use pure functions and pure data structures to build up impure database actions that we will execute later. We also try to be as explicit as possible, so we want to minimize implicit behavior, and we don't want to use abstractions that hides important details of the database. Finally, we want to have as few surprises as possible. So that means, for example, that we should be secure by default, and we shouldn't allow common pitfalls that may later lead to bad performance. And I'm going to kind of go back to these concepts as we talk about the library. So the topics today are these 5 topics. First off is the query language that we use to build up the database queries. Then we have the repo or the repository, which is our point of interaction with the database. We have the schema, which is how we describe database records as Elixir structs. Changesets is how we perform data validation, consistency checks, and we track changes before inserting or updating database records. Finally, we have multi. We use multi to compose multiple database operations that we will execute inside of database transactions. So first off, we have the query language. It's based on LINQ, and it's the query language that we build queries, and queries are just Elixir code that will be later translated to SQL or whatever language that the database is using. And as we were starting to work on this language, we started to look at previous work for these kind of languages, and there's a lot of this kind of work in object-oriented languages, but there's less work when you look at functional programming languages. But we started looking at LINQ, which is from the Microsoft .NET platform. And LINQ stands for Language Integrated Query. It was released more than 10 years ago now, I think, and it's part of all the major languages on the .NET platform. And it's called Language Integrated Query. And what that means is that the query syntax has been added to the language. And it has become part of the syntax to the language. In Elixir, we have macros. So we don't have to add new syntax to the language. Instead, we can create an embedded language, which uses macros that and those macros, of course, uses the existing syntax of the language. So this is what the LINQ looks like. It's pretty straightforward, and if you know SQL, it looks kind of what you expect. And this query is at compile time by the compiler translated to something that looks like this. So it's just a series of chain method calls. And when Microsoft were introducing LINQ, they were also adding all of these functional paradigms. So, for example, I mean, you can see here that we have the anonymous functions, and if you know SQL, it looks very straightforward. So another difference from LINQ is that Ecto queries only works on databases. In LINQ, when they in C# when they added LINQ, they also added all these methods with the same signatures that also work on in-memory collections. But in Elixir, we already kind of have that. We have the inner module, which has filter and map, which kind of maps to the where and select that we saw on the previous slide. And we have the stream module that is even more similar, which is kind of a lazy, which describes lazy operations on the collections. Additionally, since LINQ is based on anonymous function, we can't really use this in Elixir because we don't have that kind of rich introspection to look at code and then later convert it to, for example, SQL. So instead, we use the compile time macros to do the same thing. But another problem is that you have different execution semantics for databases and in-memory collections. So, for example, if we looked at the previous query, it looked up records based on the primary key, and in databases that uses an index, but we don't have that for lists, for example. So we can't really write the same queries for databases and lists anyway. And this is how it looks like in Elixir. So this query, for example, returns all posts tagged with the string Elixir. And it always starts with the from macro. And the from macro receives two arguments. The first one is p in post here. So this says that we want to query on the post schema. And we want to bind the variable p to this. So then we have the second argument, which is a keyword list. And here is where we put like the wheres and the selects and joins and group bys and so on. Yeah, and it's similar, as you can see, it's very similar to the LINQ syntax here. We also support interpolation. So everything in this query that we see here in the from part is received as a syntax tree. Is received as a syntax tree to the macro itself, so we can use this syntax tree to later convert it to something that the database understands. The problem is that since everything is a syntax tree and we want to convert it, we can't really take outside values and put them into the query. So for example, the problem here is that we want to take a dynamic variable and want to inject it into the query. But that is solved with a hat operator. So the hat operator says that this variable or expression is going to be interpolated into the query. And since this has a special syntax, we can convert these interpolated values to query parameters, so we are safe from SQL injections here. And this comes back to that we should have safe surprises. That we should be safe by default, which means that we have few surprises later. And Ecto queries are also composable. So this means that we can take an existing query and extend it later. So if we take, for example, this query that we have looked at before, and we want to add a pagination of the results, that would look something like this. So what we do here at the bottom, you see that we have added an offset and a limit. This is sort of how pagination is usually built. But the problem here is that we are mixing two concepts. We're mixing fetching posts and we're mixing pagination. And pagination is sort of the same regardless if you're fetching posts or if you're fetching comments or something like that. So we want to extract that. And that looks like this. So we took only the pagination part of the query and we extended that to another function. And you can see here that we take an original query as a parameter to this function. And when we do that, so when you pass, instead of giving post as the first argument and you give an existing query, this query will be composed. We will extend it with the offset and limit regardless of what the original query is. And that way we can just take the query for Elixir posts, and we pipe it into a Paginate function that takes the parameters for the given page and the number of items per page. And because we have that, we can easily build scopes without having any special syntax or any special macros for that. We just use the existing functionality for extending queries. There's an alternative syntax for queries, which looks like this. Instead of using from, you have macros for where, select, limit, and so on. Here we use where. And again, we can use this to extend existing queries. You can use whichever syntax you prefer. I usually prefer the previous syntax, where we use the keyword list. But this syntax can be nice when you're writing small functions like this. So we talked about composing queries, and the composability of queries builds upon a protocol called Queryable. So a Queryable has a function called toQuery, which takes some value and converts it to something that we can query. So if you remember from the first argument in the from, we passed in both. We could pass in both a post, or we could pass in an existing query. And this builds upon the Queryable protocol. So a post is a module name, which is a schema, as we can see here, and we can take a schema and convert it to something that we can query. And of course, we can convert an existing query to a query as well. We also have something called Fragments, and this is useful when you want to do things that the query syntax does not allow or does not support yet. For example, we have no function for lowercasing strings inside of the database. So you can build a macro which takes an SQL string, and we pass that to the fragment, and we pass in variables or expressions rather that we want to interpolate into the query, and we are safe from SQL injections as well. So finally, about queries, we do type checking on the expressions. So for example, we make sure that you can't compare strings with numbers. So So we have types on the schema that we will look at later that helps us do this type checking. And we'll also, for example, make sure that data that you insert matches these schema fields. And some databases will check this for you, some don't. But this is still very useful to do on the application side, because we can do, for example, automatic casting of data this way as well. So, for example, that could be something like converting a string representation of a number to the number itself. So next up, we have the repo, or repository, which it stands for. The repository is decoupled from schemas and queries. And this is the entry point where all database actions goes through. So if you don't see repo, you know that you're not interacting with the database right now. So this is very convenient because we have a single entry point where all the interaction with the database happens. And this is called the repository pattern, which is pretty common. So the repository builds upon adapters. So we have adapters for the different databases like Postgres and MySQL. And adapters pools database connections. So the whole connections to the database inside of what's called a pool. So that means that users of the repo can transactionally check in and check out connections, so we make sure that only one process can take the connection at a time, and it also means that we are isolated from failures, which we will look at next year. So this is kind of what the pool looks like. We have a few connections open as processes. And they are linked to the underlying pool, which we call my repo here. And if a connection were to go down because of a timeout, or because the process that is using the connection have crashed, and we need to clean up the connection state, we can handle that because they are linked as this, which is represented by the lines here. So when the connection goes down, we handle that by just spawning a new process. And links are bidirectional, so that means that if the pool were to go down, we can also make sure that we clean up the connections in a nice way. So yeah, as I said, we ship with support for Postgres and MySQL. There are other open source adapters available as well. So next up we have the schema. This is where we define database records. So this is what it looks like. If we focus on schema posts here, the first argument is the database table that we want to map this schema against. We usually call this the source for the schema. And inside of the schema here, inside the do block, we define fields with the name for the field and the type for the field. And the schema macro here will define a struct with fields that maps to these names, and it will define some metadata that we will later use for things like type checking and so on. And the schema will also automatically create a field for the primary key, but this can of course be disabled if you want. So on the schema we can have associations between other schemas. So we define this directly inside of the schema block. And we have basically 3 types of associations: has many, has one, belongs to. Has many are for one-to-many relationships. Has one is for one-to-one. And for both of these hash associations, we assume that the foreign key is located on the foreign schema, but on belongs to, on the other hand, we create the field for the foreign key locally. We also support has many through and many to many through join tables. Has many looks like this, so we can sort of define a shortcut association using through. So this means, so for example, if we want to get all comment authors, we can say that we can describe the path which which we reach which we can reach these users with. And this is what queries on associations looks like. We can it's called preload. We can preload direct associations, which you see on the first 2 lines here. In the second expression, we can preload nested associations, and in the final example here, we show how to do the preloads with custom queries. So you can, for example, sort the comments and stuff like that. I also want to talk about the n+1 query problem. So the n+1 query problem is something that a few database libraries has. And the problem is basically that you go through nested associations. So here we fetch some set of posts. And for those posts, we want to get the comments and the comment contents. So what could happen here is that we fetch all the posts, and then for each post, we need to get the comments as well. So that would be a separate query since we haven't fetched those yet. And the problem is that we will do one query for each post. So that's what the n+1 query problem is. So it's n queries, which is n is the number of posts, plus 1, which is the original post query. And this is a problem because we want to reduce this to only 2 queries, one for the, or 1 or 2 queries, one for the posts and one for the comments. And Ecto solves this problem by not allowing it. So if you were to do this, you would get this exception. And we solve this problem by doing an explicit preload on the comments. So this is nice because we will catch this issue early when we are building our project, instead of noticing later in production when we might get performance issues. All right, so on to changesets. Changesets are where we cast parameters, validate data, and tracks changes. So the changeset is a data structure which we start by doing a cast. And the changeset, as I said, it describes how we want to do a change. We start out by having a user. So this can be a basic. It could be just an existing user schema or a new user that we want to create. We pass in the params here. The params here are to represent external input from the user, and the final argument here with the sigil, with the name and the email, it specifies the keys that we want to extract from the param. So we make sure that if we have data that we don't want the user to change, we can whitelist the data that we actually want to take from the user. Yeah, as I showed here. We also have validations. We can validate that the email field is required, for example. We can validate for the length of the name, and we have a bunch of different validations. We also have a different kind of validations, which we call constraints. So these are a bit different because we want to validate that the email is unique for every user in the system, and the only way of doing this safely is to make sure that the database uses that the database does it, because that's the single source of truth for the data. So instead of doing this as a normal validation, we describe the constraint that the database has, and later, instead of doing the validation immediately, we take the error that the database has returned, and we later present it as a validation error. And this is what it looks like when we use a changeset. We can pass it into repo insert, for example. If everything went well, we will get back a user that we can, for example, send back an OK HTTP request for, or we get an error. And when we get the error, we get back the changeset, which describes the validations that failed and the any errors that happened that we can also present to the user. So we also have multi, sort of like changeset. Multi is a data structure that we can use to compose things with. And to show what multi solves, let's look at how you would do multiple changeset. There should be repo transaction at the top, not repo changeset. So this is a transaction where we want to do multiple things. So we want to change the role of a user, and we have sort of an audit log as well, where we want to log that this change happened. So this easily becomes pretty complicated, because if we want to do failure handling, we need to juggle these failures. We need to juggle these failures, and we need to do early escaping. If, for example, changing the role failed, we don't want to insert the audit record. So we solve this with multi, and it looks sort of like this. So we have, at the top, we create a new multi-data structure, and then we have an update and an insert for both of the change sets that we have. So user.change role and audit build are two change sets that we give to the multi. And we give each action a name, which we will look at later. So we give it the name user and audit here. Because we can use this later to reference what we inserted, or if something failed. And finally, we pipe this into repo transaction, which actually executes the multi. So if we look at the transaction call here, we can see what happens. So in the success case, we get the results. We get the user record, the user schema and the audit schema back. If there was a failure inserting the user or updating the user, we get the change set back. Or if there was a failure with the audit insert, we get that change set back. And as I said, multi is similar to changeset in this way, that we can use pure functions and pure data structures to build something composable that we can then later run to actually do the impure database actions. So we separate the pure stuff and the impure stuff. And finally, for multi, I want to show the run function. So you can't just, so you can do more than just insert and update. You can run side effects. So we have run here for side effects, where we can do anything basically. We can fetch things from the database. We can read from a file or something like that, and insert this into multi so that we can later reference this data. So for example, here we reference the post, and we fetch the all the comments for this post, and we can later use these comments to do updates or something like that. The problem with this is what it looks like in Ecto 2, the current version. The problem with this is that we have coupled the repository on multi here, so you can't build one multi and run it against multiple multiple repositories. So this is solved in the next version of Ecto, where we introduce a new argument to the function here, repo, which will take the repo that we're running the transaction on, and we can use that to do other database operations. So I also want to talk a bit about extending Ecto, and specifically extending Ecto types. So Ecto types are what we use to cast. If you remember from the Changeset, this is what we use to cast the input parameters, and it's also what describes how to load and dump database values to the database adapters, so that they have a common format which they can then use with against Postgres or MySQL or something like that. And to show custom Ecto types, I want to show an example. This is an example from Hex, where we have package releases. And in Hex, we work with semantic versioning. And we use Postgres. Postgres, unfortunately, doesn't have a type for semantic versioning. So instead, we use the simple string type, and we use a custom Ecto type to convert between a semantic version struct and a normal string. And this implementation looks something like this. So at the top, we have the type for the underlying database value, which is a string. Then we have the casting, which is how we cast input. So the input from the users is just a simple string value that we then parse into a semantic version. Or if there was a failure, the version parse will return a failure, which will then be passed, which we can then pass to the users. And then we also have load and dump, like I said, which loads data from the database and dumps the data to the database. And finally, before the end, I want to quickly talk about the changes that are in progress for the next version of Ecto. If you use Elixir, you know that there are new calendar types in Elixir. We're going to drop the custom built-in Ecto types and just use the native datetime types that comes with the language. We're also are going to do locks on the migrations table, so that if you are deploying Ecto in a cluster and you do migrations as you're deploying, you're not going to run into issues that you're deploying and running migrations at the same time. We're also adding named joins, which helps with the composability of joins. Previously, the problem with joins was that you had to maintain the you had to know the order of joins that you did before. Now we give them. Now we are giving the joins names, so that you can use the names to refer to previous joins. Finally, we are splitting the sort of the pure and the impure stuff of Ecto. So a common feature request has been that people want to use changesets to, for example, do data validation, but they are not talking with a database. So they don't want to bring in all the database adapters, all the and all the database specific stuff. So we're splitting out Ecto and we're splitting out changesets and some other things into Ecto, and we are moving all the database stuff to Ecto SQL. And this is an easy change if you're using Ecto today and you want to keep using databases. You just change the package name or the dependency name from Ecto to Ecto SQL. All right, that was it. Finally, I want to talk about this book that I'm writing with Darren Wilson. It's called Programming Ecto, published by Pragmatic Programmers. And it just went into beta this week. So if you want to learn more about Ecto, I suggest going to the Pragmatic website and check out the beta there. Right, that's it.